Welcome back to another lecture from organic chemistry. In this lecture, we're going to learn how to draw 3D shape of alkane molecules. The technique that we're going to use, we call it Newman projection. In alkane, all carbon-carbon bonds are single bonds. That means that there is a possibility of rotation around that bond. So I can rotate, I can rotate that bond or one of the carbon, I can rotate it, and that's going to give me different 3D shape from the molecule. But before we go after Newman projection, I want to actually talk about what's the difference between bond angle and another angle that we're going to call it dihedral angle. Okay. First thing is, say we have a molecule and our molecule is CH4. Okay, that's methane. So I go methane is an alkane and it's completely saturated. Okay, so you have a carbon. And that carbon is going to be attached to two hydrogens inside the plane. And you say this hydrogen called number 1, hydrogen number 2, those are in the plane. Okay. And then you will have one hydrogen, it will be pointing to you. So that hydrogen will be pointing to you. Okay. And I'm going to call this hydrogen number 3. And this one front or pointing to us. And there is one hydrogen that it will be back of the molecule. And we show it by dash. So this one, it will be back. The angle between three atoms, the angle that is between three atoms, we call it bond angle. So I'm going to highlight this. Theta is equal to the angle between H number 1, carbon, and I put this sign on the top of it to say this is a bond angle. Okay, this is a bond angle. And then I need one more atom. I can pick any atom, and I'm going to go after number 2. Okay, the bond angle between hydrogen number 1, carbon, hydrogen number 2, supposed to be equal to 109.5 degree. Why? Because you're dealing with a carbon that it has sp3 hybridization. This one is sp3 hybridization, and the geometry, or the molecular and electron geometries, they're going to be tetrahedral. Okay, so now that we know the bond angle, let's go and define the dihedral angle or torsional angle. And what's that? So let's assume you have an oxygen, and that oxygen attached to another oxygen. And I have a hydrogen atom to it, and there is another hydrogen atom here. The bond, okay, this angle, we call it bond angle. That's bond angle. But the angle between, okay, angle between first hydrogen, oxygen number 1, and then oxygen number 2, and hydrogen number 3, that angle, we call it dihedral angle. For dihedral angle, you need to have 4 atoms. 4 atoms are to be involved. So the way I'm going to represent this bond, this dihedral angle or torsional angle, I'm going to say I have hydrogen number 1, oxygen number 1, and then I have oxygen number 2, and then hydrogen number 2. Okay, I have 4 atoms are involved. So I have H, O, O, H. The angle between them, I'm going to call it a torsional angle or dihedral angle. Another example. Okay, so for example. As you see, we have a yellow atom attached to, let's say, carbon, and there is another carbon here, and one blue or purple atom there. Okay. If I turn it, if I keep it this way, okay, as you see, 1, 2, 3 bonds are there. So we have 3 bonds there, like this molecule. From yellow to the purple, okay, if I want to move from yellow to the purple one, I need to go to 1, 2, 3, 3 bonds. Okay, and right now they are facing to each other. If I turn it this way, the purple blue one completely will disappear, and it will be hidden back of the blue, the yellow one. In that case, we say the dihedral angle. Okay, so let me write it. In that case, the dihedral angle, it will be 0. So dihedral angle, it can be 0. Okay, next, let's turn it this way. Okay, now if you're looking from this direction, from here, from the yellow toward like the blue one, you see these two, they have a 90-degree bond angle. Okay, their bond angle, it will be 90 degree. So I can have theta around 90 degree. Okay, I can keep rotating this one. Okay, now we started from 0, 90, we went down, and we say the bond angle between them, it will be 180. If I turn it this way, okay, when they are completely crossed from each other, we say the dihedral angle, it will be 180. Okay, so now it's 180. Okay, and that's 180. And I can keep rotating this one. Now I got new 90. Okay, new 90. And I got another 90. And then when I turn this one, that's going to give me 0. Finally, I get to the original one, and I get 0 at the end. Okay. So the bond, the angle between 4 atoms, we call it dihedral angle. Okay. So now let's talk about how to present how to draw Newman projection. Start with this circle. You draw a circle. Next, you will draw 3 lines that the bond angle between them will be 120 degree. So the bond angle between them 120 degree, and those representing atoms that they are facing to us, or the front carbon. Okay, we can say the front atom, whatever. So this one, the one I'm highlighting, it will be the front atom. Okay, so those are going to be the front. And I want to show also I have another atom. Which atom? This one. That's hidden and is hidden behind of the first carbon. I can't see it, but I have some substituent attached to it. And the way I show the back substituent, I draw 3 new lines that they are attached to the circle this time. Okay, attached to the circle, and they are pointing out. And those are representing the back substituent. And if I superimpose them on the top of each other, this is the geometry that I'm going to get. Yellow will representing front atom, and green one, they will be the back atoms. Okay, so the yellow front and the green, they will be the back atoms. Okay. Say we have a molecule. You have a molecule like what? C2H6. So we have a carbon. We have 2 carbons and 6 hydrogens. Carbon attached to another carbon. Each carbon is going to have 3 hydrogens. 3 hydrogens. Okay, and here we go. Now, you have to keep this one in your mind that like any carbon is going to have tetrahedral geometry. So that means the bond angle between them is going to be 109.5 degree. Okay, the correct representation of any carbon, it will be this. Okay, so I have 2 carbons, and I'm going to look to the molecule from this side. So I'm looking the carbon through this direction. And I want to see what I'm going to see. Okay, so I'm looking the molecule through this direction. I'm putting my eyes here, and I want to see what's the structure of the molecule. Okay, I'm going to see 1 hydrogen pointing. 1 hydrogen is down. Okay, of course, I'm going to have 2 hydrogens. One is on my left side. Okay, left side, another hydrogen right side, but they are pointing up. Remember, we said we need to keep the angle between them 120. Whether front or back atom, the bond angle between them always it will be 120. Okay, so I got 3 atoms, and those I'm going to call them front. Okay, front. Now I'm going to have another 3 hydrogen atoms. Okay, and I will have 3 hydrogen atoms there, and I'm going to call them back, and that one also it will be back. Okay, next, let's give them label. Okay, 1, 2, 3, whatever. So this is going to be number 1. Okay, so let's call this one number 1. This is number 2, and that's going to be number 3. And then that's going to be, I'm going to call it number 4. This one it will be number 5, and that's going to be number 6. Okay, just to make our life easier so that we can track them. Okay, we're going to draw a circle. Okay, next, when we look through this direction, we see 1 carbon, 1 hydrogen atom is pointing down. So 1 hydrogen atom is pointing down. Okay, here we go. 1 hydrogen atom is pointing down, and that's going to be the hydrogen atom. Okay, so hydrogen is pointing down. And then I see 2 of them, one on the right side, another one on the left side, and let's call them hydrogen, hydrogen. Okay, those are the front hydrogen. Okay, the blue ones are the front hydrogens. The one that is pointing down, it will be number 2. Okay, so number 2 is down. Where is number 3? Number 3, it will be on the right hand up, and I'm going to write it here. And where is number 1? Number 1, it will be in my left hand up, and that's number 1. Okay, now when I put my eyes here, okay, in this direction, I will see number 4 between number 2 and number 1. So again, when I look through this direction, hydrogen number 4, it will be between hydrogen number 1 and number 2. That means you need to draw hydrogen number 4 here. Okay, that's going to be hydrogen number 4. Okay, and where is number 6? Number 6 is going to be up, and number 5 it will be here. So this is going to be number 6, and that one it will be number 5. Again, the yellow are the front. The yellow are hydrogens of the front carbon, and this time I'm going to go with green. Green, they are representing hydrogen. They are that attached to the back carbon or carbon number 2, just that carbon. This presentation, we call it numerical presentation, and the structure that we got, it has a name, and the name for it is staggered. This is the most stable structure for ethane. Okay, another one. Okay, so let's say we are looking to such a molecule. We have chlorine attached to a carbon, and attached to a carbon, so that's going to be carbon number 1, and then we have this one will be number 2, and that's number 3. Okay, so chlorine is attached to carbon number 1. Okay, carbon number 1 is not saturated. That means I need to show some stuff there. Okay, what do I have? I have carbon is chlorine pointing down, and that means I need to have hydrogen, okay, there, and another hydrogen here, okay, or pointing to us, and then I'm going to have hydrogen, forgive me, I'm going to have one hydrogen that is technically is going to be back there. One is pointing to us. Okay. And of course, this is a methyl group. Okay. When I look through this bond, I'm going to see a chlorine down here, chlorine there. And I see 2 hydrogens there. Okay. So I'm going to say front carbon, it has a chlorine and it has 2 hydrogens there. Okay. And if I keep looking, if I keep looking, I will see that here in this direction, I have a hydrogen atom, okay, one hydrogen atom, and that hydrogen atom, the one I'm going to highlight, it will show up between the chlorine and this hydrogen. Okay, so I got the hydrogen here. Okay, the hydrogen I'm going to circle. Okay, where is the methyl group? Methyl group, it has the dihedral angle of the methyl group versus the chlorine. If you look to it, it will be something around 180. This is going to be around 180. Okay, 180. So that means the methyl should be here, and that's a methyl. And of course, the last one, it will be hydrogen. Okay, this is one presentation, okay, one presentation of such a molecule. Okay, can we have another confirmation? Can we rotate the molecule over this single bond? Yes, it's possible. And if you rotate it, you will get different conformation. Okay. Another one, I want to practice this molecule and we'll be done. Okay, so front carbon, okay, the front carbon, let's say we are looking from this direction. Okay, front carbon, it has CH3 pointing down and a chlorine on the right side and hydrogen on the left hand. Okay, where is the bromine? Okay, where is the bromine? If I look to the bromine, it will show up between the chlorine and methyl. Okay, between the chlorine and methyl. So bromine should be here. And I'm going to put the bromine there. Okay, let me write a different color. That's going to be a bromine. Okay, next. What's the bond angle or the dihedral angle between the 2 methyl groups? Okay, this is the front methyl, and I wrote it there. Okay, where is the back one? The back one is here. Okay, that's a second methyl group. So in methyl group, the second one will be there. Okay, how about chlorine? Okay, where is chlorine? If I look at the molecule in this direction, chlorine, it will be between hydrogen atom and CH3. Okay, I have the hydrogen atom here, I have the CH3, so chlorine should be here. I'm talking about chlorine that attached to the back carbon, and that's another chlorine. Okay, so this is the front carbon. Okay, here you go, the front carbon, and I'm going to highlight it. Yellow, it will be the front carbon, and the red one, okay, that's going to be the back carbon. Okay, and so let's call this one for now. Let's call this one 1, and that's going to be 2. So chlorine number 1 is sitting on the back carbon, and that's going to be chlorine number 1, and this is a chlorine number 2. Okay, and this is one presentation of such a molecule. Okay. What will happen if we rotate the molecule over those, like a single bond? And every time you rotate it, you might get some repulsion, and that's going to be a good subject for another lecture. For now, thank you very much, and I will see you very soon.